Hello everyone, welcome back to Factory Discovery. Today, we're diving into a truly fascinating topic that might completely change the way you see the world. Stay with us until the end, because what you're about to discover is surprising, mysterious, and incredibly interesting. So, let's begin today's amazing journey. Part 1. The Hook. A tree that took a century to grow somewhere in a quiet forest in the Allier region of France, or deep in the hardwood stands of Missouri and Minnesota, or scattered across the ancient woodlands of England. There are oak trees standing right now that began growing before your great-grandparents were born. Some of them have stood through 2 world wars, through the invention of the automobile, through the entire history of television and the internet, simply growing, ring by ring, 1 careful millimeter at a time. And one day, a forester walks up to one of these giants, looks up at 80 or 100 feet of solid, dense, tightly grained wood, and makes a decision that will determine the fate of that tree for the next several years. This one becomes wine barrels, that one becomes matchsticks, and another becomes flooring, furniture, or fine cabinetry. It seems almost absurd when you say it out loud, that the same towering oak which once sheltered deer and songbirds could end its life as both a $500 wine barrel destined for a vineyard in Napa or Bordeaux, and as a tiny 2-inch matchstick that gets struck once and discarded in under a second. But that contradiction is exactly what makes this story extraordinary. Today we're going inside the massive industrial operations, sawmills, cooperages, and matchstick factories across North America, the United Kingdom, and continental Europe that take these ancient, slow-grown giants and split their fate in 2 completely different directions. One path leads to fire, flavor, and decades of fine wine and whiskey. The other leads to literal fire itself, 1 small flame at a time. Let's follow the log from the forest floor to its final form. Part 2. Selecting the giant. How foresters choose the right oak. Not every oak tree is created equal, and the men and women who walk through managed forests in places like the Ozarks, the French Massif Central, or the ancient Royal Forests of England are looking for something very specific. For barrel-grade oak, the prize is tight, narrow growth rings, evidence of slow, steady growth over 80 to 150 years, because tight grain means dense wood with the right balance of tannins, vanillin compounds, and porosity that will eventually shape the flavor of wine and spirits aging inside it for years. Species matters enormously here. European oak, particularly Quercus patria and Quercus robur, and American white oak, Quercus alba, dominate the barrel industry because of their unique cellular structure, which is naturally watertight yet still allows microscopic amounts of air to pass through the wood, a quality no other timber on earth replicates quite as well. Foresters mark these select trees, sometimes decades in advance, monitoring their growth and health, because a single flaw, insect damage, rot, an irregular knot, can disqualify an entire tree from ever becoming a barrel. The trees destined for matchsticks face a completely different set of standards. Here, foresters and mill operators want straight-grained, not free sections of poplar, aspen, or certain oak cuts, prized not for flavor compounds, but for one critical property: consistent, predictable burning. When the chosen trees are finally felled, using chainsaws on steep terrain or massive mechanical harvesters in flatter managed forests, the moment a 100-year-old oak hits the ground is genuinely emotional even for experienced loggers, a controlled, thunderous collapse that ends a life that began before anyone currently working in that forest was even born. From there, the felled logs are measured, graded, and sorted right there on the forest floor, already being silently assigned toward one of 2 radically different futures. Part 3. The journey to the mill. Transport and the first cuts once felled. These enormous logs, some weighing several tons and stretching 20 feet or more, need to travel from remote forest interiors to processing facilities, and that journey alone is a logistical operation most people never think about. Specialized logging trucks with reinforced trailers haul the timber along forest roads that were often built specifically for this purpose, navigating switchbacks and grades that would terrify an ordinary driver, before reaching highways that lead towards sawmills and towns built almost entirely around the timber industry, places across the American South, the Canadian Maritimes, and rural France where the local economy has revolved around oak for generations. At the mill, the first dramatic transformation happens almost immediately. Enormous log decks, sometimes holding hundreds of logs at once, feed material onto a carriage system where a head saw, a blade or bandsaw large enough to cut through a log's full diameter in a single pass makes the first cut. For barrel-grade oak, this initial cutting is shockingly different from ordinary lumber production. Rather than slicing straight through for maximum board yield, skilled sawyers practice something called quarter sawing or radial splitting, deliberately following the wood's natural grain lines rather than cutting against them, because oak destined for barrels must be split, not sawn, along its radial plane to prevent it from leaking liquid through the cellular structure. This means a significant percentage of every barrel-grade log becomes waste or gets redirected to other uses, which is one of the major reasons quality oak barrels remain so expensive. Meanwhile, logs destined for matchstick production go through entirely conventional milling, cut into manageable squared blocks called billets, optimized purely for volume and consistency rather than the painstaking grain alignment barrel wood demands. 2 trucks might leave the same forest carrying logs from trees that grew 30 feet apart, and within hours, they're already on completely different industrial paths. Part 4. Splitting the OAK, staves, seasoning, and 2 years of patience for barrel production. What happens next might be the single most surprising part of the entire process to most viewers. After the oak is split into rough staves, the curved wooden planks that will eventually form the barrel's sides. Those staves don't go anywhere near a barrel-making machine. Instead, they get stacked outdoors, in open-air yards, often at facilities in France's cooperage regions or in Kentucky and Missouri's bourbon country, and left there to season naturally for 12, 18, even 24 months, exposed to rain, sun, frost, and wind. This isn't neglect. It's one of the most carefully managed waiting periods in all of food and beverage production. During this extended seasoning, natural weathering breaks down harsh, bitter tannins within the wood and allows beneficial flavor compounds to develop, the same way aging transforms a young wine. Cooperage masters walk these stave yards regularly, monitoring moisture content with specialized meters, because staves that dry too quickly crack and become useless, while staves that don't dry enough will warp and leak once assembled. It is an industry built almost entirely on patience, where a barrel maker today is essentially relying on decisions and material prepared up to 2 years earlier by someone who may not even still work there. Matchstick wood, by complete contrast, moves through processing within days, not years, because matches require none of these complex flavor chemistry transformations, only dryness, straightness, and structural consistency for a stick that will exist for mere seconds of use. This stark contrast captures something almost philosophical about this entire industry. The same forest can produce a product meant to be savored slowly across decades in a wine cellar, or a product designed to be struck once, burn for 3 seconds, and vanish forever. Part 5. Inside the cooperage, bending wood with fire and water after their long seasoning, the staves finally arrive at the cooperage floor, where craftsmen called coopers, a trade dating back literally thousands of years, with techniques barely changed since Roman times, begin the genuinely astonishing process of bending flat, rigid wooden planks into the perfect curved shape of a barrel using nothing but fire, water, and physical force. Workers arrange the staves upright inside a metal hoop, forming a rough, cone-shaped skeleton called a rose, and then expose the interior to an open flame from a portable furnace or gas-fired toaster, while simultaneously spraying the exterior with water. This combination of intense heat and moisture makes the wood's natural lignin and cellulose temporarily pliable, almost rubbery, allowing the cooper to physically cinch metal hoops down the structure, drawing the staves into their iconic curved barrel shape through sheer mechanical force and decades of practiced skill. Watching this happen in person is unforgettable, flames roaring up from inside what looks like a wooden cage, steam billowing into the air, and a craftsman calmly hammering hoops into place with rhythmic, practiced blows, transforming something that looked impossible into a barrel shape within minutes. This same fire-bending stage doubles as one of the most critical flavor development steps in the entire wine and spirits industry. The level of toasting applied to the barrel's interior, light, medium, or heavy char, will directly determine whether the eventual wine or whiskey develops notes of vanilla, caramel, smoke, or toasted nut, meaning the cooper isn't just a woodworker, but is, in a very real sense, one of the most influential flavor architects in the entire beverage industry, even though their name will never appear on a wine label. Part 6. Sealing the vessel. Heads, hoops, and the watertight test. Once the barrel's curved body, called the shell, has been formed and permanently secured with its steel hoops, coopers fit circular wooden heads into both ends, carefully shaped and beveled to match the barrel's interior diameter exactly, often sealed using nothing more than a thin rope of natural reed or rush fiber pressed into a groove, a technique that has remained essentially unchanged for centuries because nothing modern has ever improved upon it. The barrel then faces its single most important test, the moment that determines whether months of seasoning and skilled craftsmanship succeeded or failed. It gets filled with hot water or steam and pressurized, while workers watch closely for any sign of leakage along the seams. A barrel that leaks even slightly gets pulled aside for rework or rejection, because in the wine and spirits industry, a failed seal isn't a minor defect. It's thousands of dollars of lost liquid and years of aging time wasted. Barrels that pass move on to finishing touches, sanding the exterior smooth, branding the cooperage's name and sometimes the client winery's logo directly into the wood using heated metal stamps, and a final visual inspection that treats each barrel almost like a finished piece of furniture rather than industrial packaging. The numbers involved are staggering when you step back. A single quality French oak barrel can sell for over $1,500, and major wineries in California, Oregon, and Ontario's Niagara region routinely purchase hundreds of new barrels every single year, simply because oak's flavor-contributing properties diminish significantly after just a few uses, meaning this entire elaborate, centuries-old production chain has to repeat itself constantly, forest to cooperage, year after year, to keep the world's fine wine and whiskey industry supplied. Part 7. Meanwhile, across the factory floor, the birth of a matchstick while coopers are bending century-old oak with fire and patience. An entirely different kind of industrial drama is unfolding in match factories across the United Kingdom, Sweden, and North America, one defined not by craftsmanship and patience, but by relentless, high-speed automation. The squared timber billets arrive at the factory and are fed into a machine that performs an operation almost nobody has actually witnessed despite using matches their entire life: continuous veneer peeling. A massive, razor-sharp blade rotates against the spinning billet, peeling off an unbroken ribbon of wood only a fraction of a millimeter thick, much like unrolling a giant roll of paper towels, in a process almost identical to how plywood veneer is produced. This thin wooden ribbon then passes through a cutting machine fitted with hundreds of tiny blades that slice it, in a single pass, into thousands of individual matchstick-sized rectangular sticks, an operation so fast that a single factory can produce literally millions of raw matchsticks in a single working day. These raw, pale wooden sticks then tumble into massive rotating drums alongside chemical treatments, typically a paraffin wax coating that helps the eventual flame travel smoothly down the stick's length, and sometimes ammonium phosphate treatments designed specifically to make the wood afterglow-proof, meaning the stick won't continue smoldering dangerously after the flame goes out. It's a strange thing to watch. Millions of tiny, identical wooden sticks tumbling and gleaming under factory lights, looking less like wood at all anymore and more like some strange industrial commodity, each one indistinguishable from millions of others, destined to live for only a few seconds of actual purpose. Part 8. The chemistry of fire, tipping, drying, and the strike. The defining moment in any matchstick's creation is the application of its tiny, deceptively complex head, and the chemistry behind it is far more sophisticated than most people ever imagine. In modern safety match factories, the standard since the late 1800s, designed specifically to prevent matches from igniting accidentally through friction or heat, the wooden sticks are fed in massive parallel rows, sometimes tens of thousands at a time, through a precisely calibrated dipping machine. The first dip applies a small amount of paraffin to the very tip, ensuring the flame catches instantly once ignition begins. The second, more critical dip coats the head with a carefully formulated paste containing potassium chloride as the oxidizing agent, along with sulfur, glass powder for friction, and binding agents, all mixed to an exact, tightly controlled chemical recipe, because too little of the active compound and the match won't light, too much and it could ignite unpredictably or burn dangerously hot. After dipping, the matches pass through long drying tunnels, often taking 20 minutes or more to fully cure, hanging or standing in precise rows under controlled temperature and humidity, because moisture is the single greatest enemy of a reliable match. Crucially, in true safety matches, the striking surface itself, containing red phosphorus and powdered glass, is applied not to the match head but to the side of the matchbox or matchbook, meaning the match and its ignition source are deliberately kept apart during manufacturing and storage, a safety innovation that virtually eliminated accidental match fires once it became the global standard. Watching thousands of finished matchsticks emerge from these drying tunnels, each one chemically engineered down to a fraction of a gram, is a strange reminder that even the smallest, most disposable objects in daily life often carry far more precision engineering than we ever stop to consider. Part 9. Packaging two completely different destinies. By this point in our story, two products born from the exact same species of tree, sometimes even from logs harvested in the same forest within days of each other, have arrived at completely opposite ends of the value and purpose spectrum, and watching their final packaging stages side by side reveals just how dramatically their paths diverged. Finished wine barrels are inspected one final time by hand, often by the cooperage's most senior craftsmen, checked for surface finish, branding clarity, and structural soundness, before being carefully loaded, sometimes individually wrapped or cushioned, onto trucks bound for wineries and distilleries across Bordeaux, the Napa Valley, the Scottish Highlands, and Kentucky's Bourbon Trail, where each barrel will spend the next several years quietly transforming raw, harsh young spirit or wine into something complex, smooth, and commercially valuable, a slow chemical romance between liquid and wood that no factory machine could ever replicate or rush. Matchsticks, meanwhile, move through high-speed automated lines that count, align, and insert them into matchboxes or matchbook covers at staggering volumes, sometimes packaging tens of thousands of completed boxes per hour before being boxed into cartons and shipped to grocery stores, convenience shops, and restaurant supply chains across the Western world, destined to sit quietly on a shelf for months or years until someone strikes one, uses it for 3 or 4 seconds, and throws it away without a second thought. There is something genuinely